And so I'm actually the first speaker, so I'm giving a talk just on some of my own compositions that I've already done for these instruments called Exploring Ancient Tuning Practice through Dynamically Retunable Electronic Keyboard Instruments. And I will discuss 3 different compositions that I've created in the last 2 years. Working with tuning outside of 12-note EDO has been an interest of mine for many years. Especially, I came from a computer music background, so I was always super interested in like spectral music and the sound spectrum and how the tuning was slightly different. And so originally I started writing a lot of pieces that use like Pythagorean tuning or pure tuning. And but I'm also very interested in historical music, and as I was doing a lot of research on historical music, I also found that there was some overlap with tuning systems where they had different ways of exploring intonation that was extremely interesting to me. And so the 3 pieces I'll discuss, the first is, it's called Un Naxis Fragmente for 4 voices. And this was a piece that I wrote to accompany some other pieces by Vicentino. Many of you might be familiar with Vicentino, who was a Renaissance composer and theoretician who basically created a treatise about microtonality, which I'll get to later. And then I will also talk about 2 pieces that I had premiered at this conference last year. One was sort of inspired by ancient Greek tetrachords, and the other was inspired by something I read in an ancient Babylonian music theory treatise. One thing that is extremely unique about the instruments that we have here is that they use electric, they use electric and numbers so that we can retune them at very precise amounts by giving them this information. And this is something that is very unique. With this acoustic piano, if I wanted to retune the note, I would have to physically adjust it. And historically in the past, we also didn't have like gadgets and meters that could tell us exactly how something was tuned. So people had to rely on different techniques like listening for specific beatings or listening for no beatings in order to tune. And so I find it very fascinating that it's so, in a way, very easy to just tell the software, oh yes, I want this pitch tuned at -14 cents, and it will be tuned at -14 cents, and you can be very specific with it. And so I found that a very interesting avenue to explore, and a way in which I could sort of start to delve into exploring these systems as a compositional device. So the first piece that I will talk about was composed to accompany all of the fragments that Vicentino wrote using his tuning system that he developed in this treatise that he wrote in 1555 called Ancient Theory Applied to Renaissance Practice. And I mean, I guess it was ancient theory applied to modern practice at the time, but it's not modern anymore. And he had postulated that one of the ways that they could get deeper into affect and emotional impact was to go back to the Greek tetrachordal system. And the Greeks had ancient Greeks had originally used 3 different kinds of tetrachords, one which was diatonic, another which was chromatic, and then they also used enharmonic tetrachords, which used steps that were smaller than half step. And so he thought by mixing those systems in a piece, you could increase the emotional impact and drama of the piece. And so he actually wrote some fragments that mixed those. The other thing that Vicentino did was he designed and invented basically this instrument called the archicembalo, at least gave all the planning for it. And this was a keyboard with 36 keys per octave so that you could access all of the small intervals that were within the enharmonic system, for example. And the reason that this was developed was so that it could help the singers to learn the pitches and learn how to tune, because most of this music was also intended to be sung. And so this piece that I have composed for these voices and using this is actually, it's an even further departure, because Vicentino had used the ancient Greek tetrachords, but he was coming from the Renaissance sort of thought perspective, and so the way he applied the tetrachords was not at all how the Greeks thought of them, but more how Renaissance musicians would think about it. And I did something very similar, so I created 3 short vocal fragments to go between these pieces that actually used his notation and used his tuning systems, but they're actually also written from my modern perspective. So I'll just play a very short fragment of this so you can hear. So that was just a short example, but what I did in that piece was that I started in a diatonic tuning, and throughout the piece, basically, it all became transposed up this very small step of 41 cents that was separating the keys in Vicentino's keyboard. And the reason I brought this piece specifically into this talk is because of the way that the performers rehearsed. And interestingly enough, at the point at which I had composed this and at the point at which they were working on this, we had already started our research and exploration into the e-piano retunable system. But for this performance, someone had programmed 2 keyboards with 12 keys per octave, so not accessing the full range of what Vicentino's keyboard did, but almost the entire range, and basically detuned them by about 41 cents so that the performers could actually practice the Vicentino works and the pieces that I composed using these keyboards as a reference. And so that's one of the things that such instruments have potential to unlock. The next pieces that I will explore all have to do with electronic keyboards, and they were written actually for the symposium last year. And so my starting point for the first piece that I composed was ancient Greek tetrachords. And for many of you are probably familiar with the ancient Greek system, but for anyone that isn't, they used a tetrachordal system in which each tetrachord spanned about exactly perfect fourth. And they had 3 different overall kinds: diatonic, chromatic, and enharmonic. One used whole steps as the primary basis of the system, the other used half steps, and the enharmonic system used steps smaller than a half step. And of course there's multiple versions of this, I'll show you in just a second, based on the period of history in which the theoretician was talking about it. And I composed this piece called Tune Down, which explores moving from one tetrachord type to another during the performance. So I essentially move from diatonic to enharmonic over the course of the piece. And I just have a couple images that I can show just to give an example of how different the tuning systems were, even within the same type of tetrachord. So here is an example of just 4 different types of diatonic tetrachords. And then there are some chromatic tetrachords, which are also very different, and then enharmonic. And what's interesting is I actually used the descriptions that I had taken from a text that described the theory, but the descriptions were taken from the original sources from, for example, Aristophanes or Ptolemy, and they all had different ways of describing how the pitches related to another. So the sense I added, but For example, the first one, the theorist described it in steps. And I actually took that description to ascertain how many cents were different based on what a step meant in a system in which it spanned 498 cents. But others used ratios to describe it. And so it's interesting because it's postulated how they actually tuned. Obviously, they would need to use their ear, but in order to tune things that are out of tune, you have to somehow know the rate at which the beatings would occur. So it must have been extremely difficult to manage these tuning systems, and is a question of how did they actually sound, whether they sounded like it was written. I'm going to play a short excerpt from this piece, and then I'll just talk a little bit about the progression throughout. So I think you can already get an idea that there's this sort of melody going through, but it's starting to shift the intonation. And so essentially the piece, it starts as a focus of the initial tuning system. So I retune all 12 pitches of the keyboard, and every octave is tuned the same. And I start with 2 tetrachords which are disjunct, so one from A to D, and then one starting from E. And they're gradually compressed from diatonic to enharmonic. And so the musical material, however, remains the same. So actually the written pitches on the score stay exactly the same, but the tuning of the piano keys changes. And so you can see this is actually an excerpt directly from the score, which is the instructions to the performer or the person realizing the Max Patch software, that the tuning changes 6 times throughout the piece, and it indicates which pitches change. And so gradually the diatonic notes are lowered, so that by the end of the piece, actually the C is lowered almost, it's a full diatonic step. The final piece that I'll talk about was actually inspired by something that I read in many papers when I was researching ancient Babylonian tuning, actually, and how they realized their tuning system. And it is how they discussed the tuning of string instruments, and specifically how to change from one mode to another in a string instrument. And so there are many, many different interpretations of this, but I thought this was the most clear to show what I'm about to show, and that is how to tighten the strings in order to make the pitch higher so that the scale gradually shifts up a half step, one pitch at a time. There's also many other interpretations of it. I showed the original so that you can see what it originally looked like and what people had to describe. But essentially it's taking a scale and one pitch at a time by tightening a string, shifting to another scale. And that was the way that they described their something that we would consider modes or similar. And I thought that would be an interesting way to approach the movement from one way to another in a piece. And so I wrote this piece called Tune Up for the Frescobaldi and the E-piano. And I actually looked at what the difference was between like the certain pitches of the equal temperament in the piano and the quarter comma mean tone in the E organ, and then also with the added keys. And so what I did over the course of this piece is that I shift the several keys on the piano up 41 cents, so that while they're matching some of the keys on the organ at the beginning of the performance, by the end of the performance they're matching other keys so that different harmonies are unlocked. And I'll just play like a couple, a minute or two from this. So you can already hear a little bit of intonation differences between the two. And so basically the E piano, what I actually did was I changed it to normal quarter comma mean tone. And the Viscount is in quarter comma with extra enharmonic keys. And the notes in the E piano basically shift one at a time up 41 cents. And so I'll just show you what the tunings look like. So the first tuning looks like normal quarter comma mean tone, and by the end everything is up 41 cents. So one pitch at a time. And the E organ, as you can see, it starts with the added key values are given here. So the added key of D flat is plus 17. And you can see in tuning 1, the C sharp or D flat is -24, so it's actually corresponding to the existing pitch, not the added key. And by the final tuning, it is +17, so it's actually corresponding to the added key. So I hope you enjoyed examining some of the ways in which I approach these systems musically, and how they could be, these instruments can unlock the potential of exploration of these kind of things. And especially something I find extremely unique about these instruments is that the tuning can be changed during the piece. And so this is what enabled things like me making 13 different tuning changes within the course of a performance, which would not be possible on a regular piano necessarily. And it's much easier on these instruments. And there are many other things that I think these things can unlock, but that's something specifically that I enjoy exploring, because I enjoy working with different ways of using harmony and adapting enharmonic and microtonal harmonies for to create my own musical language. And so I would just like to say that, of course, I was not intending to replicate the systems. There are many people that really do like to look into actually replicating ancient Greek tetrachords or finding out how these tuning systems really worked. These pieces were not at all designed to do that. They just use them as sort of an inspiration of different ways we can explore tuning, and different ways that we can explore relationships between pitches in a piece. And so thank you very much for listening and your attention.
So, well, I am Pablo. I mean, unfortunately, I haven't actually specifically wrote for microtonality, so I'm speaking about a piece that I did a little bit before the project started. It has pitch implications, and it was intended with that intention, but not exactly in a very controlled way. I just thought it's a piece that actually probably got me invited to participate in the project. If I probably didn't do it, I wouldn't be here. This is a piece that I did for Rogers Opus 2609 that is on the Organ Institute here in the CUB. It's an electronic organ that is attached to a multi-channel system. So in this moment, the main objective in my head is how to use spatialization and find avenues to use it as a compositional material, and not as a so to make it clearly, to use the spatialization as a compositional element, and not a simple consequence of using the system. In that regard, I use spatial modulation synthesis, and the very cool aspect of it is like using the spatial modulation. You have this modulation on the space, and then you have frequency modulation in a sense. So the pitch perception starts to change. This is everything happening while the sound is rotating at very high speeds. And the piece, pretty much the piece is one of the pieces where my attitude was to simply grab all the material from the system itself. So I can go and explain the system. So this is an organ that has 3 manuals. The very particular aspect of it is that while everything is attached electronically, each manual and the pedal is separate in stereo pairs for the manual 1, 2, 3 and the pedal. So I have 8 stereo. This is a very big organ with 90 stops. And the multi-channel system is 20 speakers that are, if you want, I can describe it to you in a visualization. you have a lower ring, let's say, that is ear level, and then you have the upper ring, and you have a sort of different speakers, 4 different speakers in the surround back. So part of the process of the piece is to distribute each manual in each of the rings, and there's 3 subwoofers where the pedals are distributed. I thought this also in a way where the real organs always have their sound producing sources separate in the space, so that was, I was trying to be as analogous as possible. In this regard, the limitation here was my maximum modulation speed, or my maximum frequency modulation was 48 kilohertz, as that is the maximum amount that I could go with the setup of the system. So to speak about a little bit of the electronic process, this is the way I used to approach the spatial modulation was quite destructive, because I'm just actually slicing the sample and put it in a different speaker. So here's a little overview of my diagram of how I did my routing. The logic of the code is extremely simple. So what I will do is to have a count that is counting the sampling rate that is going on, and if it corresponds with the output channel, then it sends the audio output through there. And in a sense, there is no panic. The motion is just made by the fact that there's an active signal on the speaker. Well, in this regard, like when I was talking about, I try to use the system to bring the musical material. So by being at 48 kilohertz, the most approximate pitch in the tempered scale is an F sharp. And something that was also, I guess, quite beautiful for me was like going from one sample that is an F sharp. Then if I go to 2 samples, then it's half the sampling rate. So I go to the one octave lower. So I have the subharmonic series of F sharp. So with that in mind, I started my musical material that is played on the organ with an F sharp. So I have always this parallel correlation. So all my modulation, it's always going to be a reflection of what the player is playing, and the electronic process is doing the contrary motion in that sense. In that regard, I was exploring these relationships in between the modulation with the pairs of it. For the timing of the piece then, because this was it's a very natural relation, I decided to use golden ratio for the distribution of the time, so I thought it made a lot of sense. Maybe not. And the musical structure was very simple. In the sense, I guess it's also a piece where I was trying to understand this relationship. So it's a piece with a very contemplative attitude, I guess. So I have a very gradual process so I can go and try to distinguish what is happening. The repercussion of the process. So I will have this gradual addition of stops. They are completely held, and then I'll start adding layers of processing to each note activation, and then I have these old relationships. I play with these old relationships. I don't know. Here, there's the start of the F sharp. So like there you see that the harmonic series is rising. I have other centers in each of the manuals, and for each note, I will start a modulation process that goes around. Another thing that I did is to avoid this unidirectional sense of movement. I have synchronicity of doing the same process in both sides, so it was just the feeling of the space and not directly a trajectory sense of spatialization. I'm sorry, I'm going to skip. I can sort of show you maybe the audio so you have an idea. This is a very fast modulation. Oh, I'm sorry. I mean, unfortunately, this is a stereo recording, so it's very hard to get the feeling. Because something also I like about this specialization approach is very visceral. If you are in the room, it's very easy to feel also in your body the implications of the spatial modulation. So here, this is our very static pitches, but you can still you can already sort of hear like the pitch shifts because of the modulation. Through the piece, I start to doing a gradual transition to have a little bit of mix of the sound organ and lowering the speed also to see the point of cross modulation, the cross perception. So at the very end, I have this slower, but not so slow movements. So you will start hearing the rhythm instead of the pitch modulation. In any case, I don't know how I'm doing on time. I'm not. I think I feel very rushed. I'm doing okay.
Yeah,
good. So this is observations that I got from after doing the piece. Probably thinking now that it's something I thought about now that we have this Frescobaldi. And now in a future approach, I could actually do the harmonic series with the actual deviations in the keyboard, and I could actually have a better correlation of the subharmonic series, because in this case I have a equal temperament in the organ, and I didn't modify this, but now it's something that I would like to do. One problem with the system is that it's extremely site specific. Outside of this specific organ, I have big troubles in actually performing the piece, and one of the future approaches is that I really would like to find avenues of doing with acoustic instruments, try at least to get as close as possible to the intended output that I want. I mean, this comes with a new set of challenges that I will have to address. But anyway, it's something quite exciting. And also I need to take into account that probably, depending on the amount of speakers, the sonic result, the modulation result, the pitches that can emerge is very different. So something I would really like to systematize, to try to find patterns that I can use to actually to have now a more controlled microtonal approach of the result, and it's not just a consequence of the system doing what it does. Let's talk about this. And also another thing is because this was a computer music centered project, my approach was very destructive, intentionally very destructive by slicing, so I have a lot of glitch sound and that stuff, but I think it will be also a very interesting way to also have these less destructive approaches to the spatial modulation. And then, yeah, definitely will continue now that this is working. Last times I didn't compose for the Viscount and the Fresco Valley because I was spending a lot of time programming and sampling for it, so I was a little bit overwhelmed. And thank you very much, and I'm very looking forward for any question or any observation. Please.
Yeah,
okay, let's see. Okay. Much like Alyssa and Pablo, I will also be talking about some of the pieces I wrote specifically for the last two iterations of this concert. I will mostly be concentrating on the E-piano and the software for that. And yeah. Anyway, so calling it a C series because all the pieces are called, as you will see. Do I have them here? No, I don't. Follow the C, control the C. It's always based on C. I don't remember the exact reason other than the C is right in front of you. It is a good point to split the keyboard to do different things into the two halves of the keyboard. So, so please don't ask me for any more details than that. I will not have a good answer for you. In any case, yeah, so it started in 2022 with solo pieces for the E-piano. Last year I wrote a piece for a duo for the Viscount with the attachment and the piano, and either today or tomorrow, I can't remember, I have a piece for acoustic piano and E-piano. You get at least a sneak peek of the first page of the score at the end of that. So, in terms of the let's just go to the next one. Follow the C was the first piece that was written for the E-piano with a microtonal patch. And for me, in terms of the microtonality, in those early pieces at least, I'm using EDOs, so the equal division of the octave, where I will, in this piece, as you can see, it is between 9 and 16 EDO, and it's kind of randomly chosen by the patch when that changes and how that changes, and it's different for the low notes and the high notes on the piano. But in terms of the microtonality of it, for me it's about the timbre and the beatings between different notes that are not supposed to go together in equal temperament. So I don't have a theoretical structure that goes through it or how the EDO changed necessarily. So for me it was all about listening to the different EDOs and putting them together to see how the timbre of the piano changes and where the beatings are and how those things kind of work. That's what interested me in this approach. Beyond that, because we have an E-piano and we're working with MIDI, then the other level of those pieces are, I have a MIDI controller. What can I do with that? Not just treat it as a piano, but go one tiny step further at least, and since we're using technology, let's add one more layer to that. So in this piece, I kind of converted it into a player piano, and what I mean by that is as the pianist is playing, certain portions of what is playing is delayed. It is sort of record it on the computer and then play it back a measure later, 8 measures later, 22 measures later. So there's this constant remembering, but not quite right, because every time it is played back, it is retuned. So it is never quite the same. It's always a little bit different, which makes it really also difficult on the poor pianist, because what he played before is coming back while he's trying to count and keep it all together. So we can talk to poor Forrest in the back, who was performing the piece. Here's actually the full score. It's a short piece, and as you can see, it is literally follow the C. The right hand only plays C's. There's nothing else. The left hand has mostly C's. There's a couple of other pitches in there, and anything else is done by retuning the piano. And the different pedals, the different things, turning loop points on, off, or changing. No, here we don't change the tuning of the pedal. That's the next piece. But it decides what gets delayed. So, yeah, you can hear at the beginning the slide shifting, and then once we get the octaves, of course, because we have slightly higher and lower EDOs, then we get the bigger shifts. And also every time you perform this, those shifts are going to be different. So this is not set. As I said, the patch is randomly choosing between those, in that range between 9 and 16 EDO. All the time, so that's just so this is what the patch looks like. Just we have those modules. For those of you that wrote for this, you will have seen those because I emailed them out. So simple EDO modules. We can set them in real time and change them to anything we like, and it all works. Let's see. And the inside, it's very simple, but the MIDI messages get delayed for a certain amount of time and then played back. So by the end of it, if you go to the website and want to listen to the piece, at the last 30 seconds of the piece, Forrest has already done playing, and it's just it runs through all of the delays as the piece is finishing. So. I kind of like that visual of the pianist is done, but the piece isn't done, and we're still actually performing. So yeah, that was Follow the C. The next one was Out of C. Again, the right hand still only plays C, just like in the first piece, and the left hand has mostly scalar patterns. But this time. exploring more the extremes of the EDO. So anywhere from one EDO, so I'm not sure what that means, but there it is, up to 2048. Again, just to see how does the piano react to that, because at that point the entire range of the piano is squished down to a quarter tone, less, I'm not sure, I don't remember, I'm sure I did the math at some point. So it is not really possible to get that resolution anymore. So how does the software react to that, how does the piano react to it? And that was the point of trying to push it and see what actually happens, because again, it's not something that's physically possible. Yeah, so throughout the piece, let's see, those are my tables of EDOs for the right hand and the left hand. You can see we are jumping around from starting normal, going down to one EDO, and then shifting around. And the pianist is responsible for moving through those EDO sets by pedaling, basically, with the left and the middle pedal. Yeah, different. Let's see. Yeah, as I said, just C in the right hand, then we have those octaves, which, as you will hear in a second, get quite interesting when we change to 2 EDOs, or 4 EDO, 8 EDO. And we're forced again. Patch looks pretty much the same. Again, we have those modules, those EDO modules, but the magic happens underneath. It's, if you're interested in patching, you can come talk to me. But it's very simple in terms of the patch for this one. The next piece, controlled by C, or technically in the score controlled by 2,826 Cs, because by the end of the piece the pianist will have played 2,826 Cs if he happens to follow the score. So a lot of Cs in there. And I think by the end of this piece, Forrest was actually bleeding. We literally made him bleed. This piece was somewhat inspired by Georg Ligeti's Etude, Touche Bloquée, where if you know the piece, Ligeti, you silently depress a number of keys, and with one hand, with the other hand, you play very quickly patterns over it as if you're playing a scales, but because they're already pressed, you're getting complex rhythms, right? And by changing that, you can he changes the rhythmic makeup of the piece. Because we have technology, we made it easier, so certain keys just will not play. So, oh yeah, here is the Ligeti piece, where you have the help pieces, the help pitches, and you're playing over them. I'm trying to find my, no, doesn't say here, I'm going back here. So basically, it's a visual representation of what gets played and doesn't get played. So on the right here, for every 6 pitches played, only 4 will be actually heard, and in that configuration. And on the other side, for every 47 pulses, we'll only hear 6. And I can change that, of course, interactively in the patch, how that works. And there's a system on how it rotates and which pitches. So throughout the piece, even though Poor Forest is playing and a million notes, only a fraction of them at times will be heard and triggering things. This is the first and towards the end somewhere the piece, but as you can see, there's lots of repeated Cs, which internally also, as we're playing the middle C specifically, the Cs are counted, and then that of course will adjust the tuning and the EDOs or certain other things in the patch. So we'll try play a little bit of that. So the next piece was the duo for the piano and the organ. And for the piano part on this one, for a long time in one of the rooms here, there was a piano by Georg Friedrichs' overtone piano that he tuned to the overtone series. And so I kind of thought, well, I can do this easily on this piano. I can tune it to any overtone series I like with any fundamental. I'm not restricted to like he was. I can't remember what it was tuned to, which fundamental. But, so the plus a C, play a chromatic scale. Overtone piano. On top of that, for this piece, even though I'm changing to A flat or F, those pitches are actually, those fundamentals, all detuned to the C overtone series. So it's not an A flat or a G in C equal temperament, it is an A flat or a G as it appears in the overtone series of C. And that is paired with the border comma mean tone of the organ over here. One thing that I haven't really mentioned yet. Alyssa kind of alluded to it, and that's the notation of the piano when you change the tuning. It is always like, I would almost say tablature notation, because it is what you play, but it's definitely not what you're gonna hear. And so actually at the conference last year, we performed this piece twice, once in equal temperament, so you hear as it is written, exactly, and then once with the overtone, the piano, and the mean tone tuning, which I thought was sort of an interesting experiment to actually to play and hear what's written, and then to play and hear what's not written in a way. But so I think, yeah, the first one, I'm just going to play the beginning of the piece in equal temperament, and then repeat with the mean tone and the retuning. The piano is not as an overtone piano the entire time, so we can turn it off and then play normally and switch between those two. That is the first page of the piece that's going to be performed shortly. Well, at some point during the conference, I don't remember when. Yeah, so just to conclude, what I'm trying to do, especially in the series and going forward, because I plan to write more solo pieces and duo pieces and probably trios coming up for the next one, is to not just focus on the microtonality or the microtonal implications of those instruments, but also we have the technology. How can we change whatever MIDI settings those keyboards allow us to. Or in the first piece, we can delay MIDI streams, we can split them, we can have different tunings with different octaves if we so choose, or portions of the keyboard. So all of those things are all of a sudden really possible, really easy to implement if you have any, little bit of knowledge of computer music. So that's sort of what's really interesting to me about this. Hopefully to some of you, and if you have any questions, shoot. And thank you.